Okay, in this tutorial I'm going to walk you through how to write balanced formula equations. So let's get straight into it. Alright, so when we write balanced formula equations, it's writing the formula, so that's the ones with the symbols and numbers, but we have to balance them, and I'll show you what I mean by that. So let's take a chemical reaction. Now you've probably all reacted hydrogen with oxygen to make water. So this is what you've probably learnt as the POP test, where you test for hydrogen. If you collect some hydrogen in a test tube, probably after you've put a little strip of magnesium or zinc or something like that into acid, so hydrogen plus oxygen, when we light it, when it burns, we make water. So, you probably know the formula for these things. You've probably seen those before, but just in case you haven't, hydrogen likes to hang around in pairs, so hydrogen gas is actually H2. Oxygen also likes to hang around in pairs, so it's actually O2. And water consists of basically H2O. You probably all know that formula. Okay, so we have the formula for these things. We've got a formula equation here, but things don't quite add up. Basically, everything on the left-hand side, the reactants, must equal the amount of product on the other side here. And basically, if you imagine this being like Lego, if we've got hydrogen made out of two bits of Lego stuck together, and oxygen maybe two larger pieces of Lego stuck together, we can pull them apart and rearrange them to make water. But we still have to have the same number of pieces that we started with and that we finished with. So for instance, on this side, I've got 2 hydrogen atoms. Over here, I've got 2 oxygen atoms. But over on this side, I've got water is made out of 2 hydrogen and 2 oxygen and 1 oxygen atom. So here we've got 2 oxygen atoms, but here we've only got 1. So this doesn't actually balance. You know, what happened to the other oxygen? Well, it's not actually released as oxygen. We don't have oxygen left over, but what actually happens is that it still goes into making water. And you may have learnt that to make water in the perfect combination, you would need 2 parts hydrogen for every part oxygen. And that's basically what we have to do with this formula. We have to adjust it so we have the same total amount of things on this side as on this side. And that is actually called the law of the conservation of mass. Stuff can't just appear or disappear out of nowhere. So we need to make sure that everything we've got on the left, we've got the same amount on the right hand side. So the reactants and the products have the same total mass or number of atoms. So how do we do this? Basically, I recommend you start with the most complex formula. So looking at this, I've got H2, O2, and I've got H2O. The H2O looks like the biggest or the most complex formula. So I'll start with this one. Start with this one here. So starting with that, if we look at the number of hydrogens, I've got 2 hydrogens on this side, and I've got 2 hydrogens on that side. So the hydrogens are happy. At this stage, I've got 2 hydrogens on this side, and I've got 2 hydrogens on this side. So the hydrogens are happy. We've got the same on each side. Oxygen, we've got 1 oxygen on this side, but 2 oxygen on this side. So I've only got 1 on this side, and I've got 2 on this side. So I'm going to need double on this side. I need more oxygen. Now I can't just put a 2 here, because that would actually no longer be water. H2O2 isn't water. It's actually something we call hydrogen peroxide. It's something you might use to bleach your hair. So we can't just put a 2 there. It would actually change what we actually have, the substance we have. Water is H2O. So how can I get 2 oxygens on this side? Well, what I can do is I can put a big 2 in front. This now means I've got 2 lots of water, 2 of the whole thing, which means I'll now have 4 hydrogens and 2 oxygens, double of everything. So now let's just check, does everything balance? Well, now I've got 2 oxygens here and 2 there. Oh, but my hydrogens, they've changed a little bit. So hydrogens, I've got 2 on this side. Oh, I've now got 4 on this side. So how could I get more of these hydrogens? Well, again, I can put a big 2 in front, and now I've got twice as much hydrogen, 2 lots of 2. I've got 4 hydrogens on this side. My hydrogens are happy. Alright, on this side I've got 2 oxygens, and on this side I've got 2 oxygens, so that formula is balanced. So let's do another example. Let's combine aluminium with oxygen. So you know oxygen likes to hang around as O2. Alright, and we're going to make some aluminium oxide. Now, aluminium oxide has the formula Al2O3. And if you didn't know that, you could actually use an ion table, or you could work out what charge each one forms. Aluminium makes a 3+, and oxygen makes a 2-. And if you balance that out, aluminium and oxygen will combine in that ratio to make Al2O3. So that's the formula for aluminium oxide. If you're not sure about that, have a look at my video on balancing ions for ionic compounds. Anyway, let's get into this one. So again, my tip is that you start with the most complex formula. So let's start with this one on this over here on this side. So if we look at this, we've got over here 2 aluminiums. Okay, so that's fantastic. We've got over here on this side just aluminium on its own, so we can just whack a big 2 in front. And now we've got 2 aluminiums here. Okay, fantastic. Now we've got 2 oxygens here, and we've got 3 oxygens here. Now remember, we can't just change these formula. They would change what we've got, but we can just add more of each. So I've got 3 oxygens here, and I've got 2 here. So how can I get 3 oxygens out of that? Well, I could maybe go 1.5 oxygens. That would do it. So 2 aluminiums there. All right, and 1.5 lots of 2. That would give me 3 oxygens here and 3 here. Okay, unfortunately, you can't quite do that. You need to use whole numbers when you're balancing equations. Sometimes in a combustion reaction, they actually accept decimals or numbers that aren't whole. So here, guys, what we need to do is, if you get into a position like this where you've got 1.5 times something, what you do is you just times everything by 2. So we go through, we just double everything. So this first one over here, we had 2 aluminiums, so we're going to make that. We're now going to make that 4. So it gives us 4 aluminiums. Our oxygen, we're going to make that 3 oxygen. So 1.5 times 2 is 3. And we're going to double everything here, the aluminium oxide. We're going to double that. And so let's just check that we've balanced it now. So we've got 4 aluminiums here, 3 lots of 2. We've got twice as much now. We've got 6 oxygens. Over here, 2 lots of 2. We've got 4 aluminiums, and 2 lots of 3. We've got 6 oxygens. So you can see here on this side we've got 4 aluminiums, 6 oxygens, 4 aluminiums on this side, 6 oxygens on this side. So that's now balanced. So if you ever get to that position where you need 1.5 of something, just go through, write it down as 1.5, and then go back and double everything and just check, and you should find it balances. So again, my tips: start with something that is the most complex one. Leave an element, especially if there's only one of them. So we've only got one type of atom, like oxygen here, or aluminium. If you've only got one thing in there that's an element, leave that one till last, because you can adjust that without it affecting any other element. So start with the most complex, leave the simplest or a single element on its own until the end. Sometimes it also pays to start with things where there's so for instance, like oxygen here is only contained in one compound on this side. You'll probably see what I mean by that when we do a few more examples. But the gist of it is, guys, I'd say, like I said, start with the most complex one. Just count up the number of atoms, put a number in front on the other side to get the number you need, and then if you find as you go through you're ending up with a decimal place, just multiply through so that you get whole numbers all the way across. And like I said, do your final check, just check that everything balances out. I often just do it drawing these lines underneath, count up, count the number of lines on each side, and then you've checked it. Cool, I hope that helps.